All right, so now instead of just factoring an equation, or a polynomial, now we're going to have an equation where we actually solve for the variable. So this is where, you could graph the left side, graph the right, see if they intersect. And then, that'll give on your calculator, and then that'll give your answer. But so here's how it goes. We've got something times something equals 0. All right. Well, the only way you can multiply two things together and get 0 is if one of them is 0. So that means that if 3y minus 8 were equal to 0, then you'd have 0 times all of, times this stuff, and that would be 0. But what if 4 plus y was equal to 0? Well, then you'd have 0 times whatever that is, and yeah, that would equal 0, and that would work. So that is a technique for solving equations. Factor it down, which is already done for us this time. Okay, factor it down, and then set each factor equal to 0 and solve. So if we add 8 and then divide by 3, we get 8/3, or 2 2/3. And then over here, I'll take away 4, and -4 is another answer. So y equals 8/3 and -4. Those are the two solutions. Now this one is not factored for us, so we'll do that. So we'll factor out the GCF of 3w. And now that it's factored, we can set each factor equal to 0 and solve. If I divide by 3, I get w equals 0. And if I subtract 7, I get w equals -7. And those are my two solutions. So sometimes, yeah, you just got to pull out that GCF. I didn't have to pull the 3 out. All I really needed to pull out was that w in order to proceed. But, nothing wrong with pulling out the 3. Now this time we've got 3 terms. Okay, no big deal. So I'm going to just, the leading coefficient, a, we call it a, is 1. Therefore, I can just, kind of shortcut it and say, all right, well, we're going to have a +7 and a -1. Those two will add up to 6 and multiply to -7. So it's cool. And now that it's factored, okay, using what we've learned, I can set each factor equal to 0. And I get -7 and 1 for my two solutions. So if it's not factored for you already, you got to factor it. Okay, well, this one's slightly different because now not everything is on the same side. Okay, you need to have it set equal to 0 so you can do that 0 product rule trick I was discussing at the beginning of this video. So if I add if I add w squared, oh brother, if I add 20w to both sides, okay, if I add 20w to both sides so that I can get everything on one side, now I've got that 0 there on one side of the equation. Now this problem is like the last one. Okay, but our leading coefficient, our a, is not 1. So I'm going to do, I'm going to say a times c is 100. And so 1 and 100 multiply to 100, 2 and 50, 4 and 25, 5 and 20, and I think that's it. Could be. 10 and 10, duh. Okay, and I need a pair that's going to multiply to 100 and add up to 20. So 10 and 10. Oh, this is a perfect square trinomial. Okay, we could have, done with perfect square trinomial. I don't tend to think of that usually, so whatever. All right, so 4w squared plus 10w plus another 10w plus 25 is 0. Throw in some parentheses. Hopefully you are getting really good at this whole, at these factoring techniques, okay? Because the problem, we're right now starting to see where the problems get a little trickier and you've got to do a lot of factoring inside of a problem. Okay, so you want to get that factoring stuff down as fast as possible. That's half of this course. All right, so we got that. I can pull out a 5. And what's inside the parentheses matches, like just like it's supposed to. So then I get 2w, you know, it's getting, I'm running out of screen. Okay, 2w plus 5 squared, or 2w plus 5 times 2w plus 5. All right, and then at this point, I could set both factors equal to 0, or I could, they're the same thing. They're both 2w plus 5. Or I could just square root both sides because it's a perfect square trinomial. Okay, and then I can take away 5. And then I can divide both sides by 2, and I get negative 5/2. Okay, but wasn't there supposed to be 2 answers? Because the highest power of the variable was 2. Yeah, there were. In fact, that answer, it was just that negative 5/2, that was the answer twice, okay? If I write it out the long way, and then I say, oh, I've got, 2w plus 5, set that equal to 0, and 2w plus 5, set that equal to 0, yeah, I'm going to get negative 5/2 for both, but it's going to appear twice. So I get 2 solutions. They're just not distinct. They end up being the same number, but I get one from here and I get one solution from there. So I still get 2 solutions. Okay, on this one, well, it turns out what we got to do is multiply that out. Okay, so that'll be v squared. Remember, it's v minus 4 times v minus 4. So you have to multiply it out the long way, dance it out. So it's going to be v squared minus 8v plus 16, as it turns out. Okay. Now I got to get everything on one side of the equation like we were doing on that other problem. So I'll subtract v squared from both sides. Get negative 8v plus 16 is v squared minus 5v minus 2. Then I will add 8v. It doesn't matter what order I move these things. Add 8v to both sides. So I get 16 equals v squared plus 3v minus 2. Then I will subtract 16. And I get 0, finally, equals v squared plus 3v minus 18. All right, so you got to get everything on one side, combine like terms, all that fun stuff. Now, the leading coefficient, or A, is 1. So I can try to shortcut this guy. I'm going to have v and v, and then maybe like negative 3 and positive 6. That'll multiply to negative 18 and add up to 3. Okay. So now I can set each factor equal to 0. And when I do, I get 3 and negative 6. And that's how you do those. Okay, so the only difference is you gotta multiply this stuff out, and then you've got to get everything on one side, combine in like terms, so you end up with the 0. Okay. And then it's like the preceding problems.